Hello, my name is Yuval Shavit and I'm R&D Manager at EcoWave Power, and today I'll be presenting our wave energy pilot, Advancing Wave Energy with Real-Time Data and Forecasting. A bit of a pilot overview. So our objective is to support wave energy commercialization by providing accurate nearshore wave energy data for assessing locations for future wave energy converters worldwide. The current challenges is that wave energy potential is often estimated using met ocean data or satellite data from distant locations. On-site measurements are required for accurate wave energy forecasting, and currently there is no exact way of knowing about the correlation from met ocean data and on-site measurements. EcoWave Power's pilot project is testing 5 types of sensors to measure wave data and comparing the sensor data with Met Ocean satellite data to assess accuracy and forecast future sites' energy potential. Additionally, to develop the capability to measure every single wave and calculate available wave energy at a higher resolution. The impact is to advance wave energy projects and to optimize energy forecasting and maintenance processes. And the broader benefits are for businesses, research institutions, and universities to gain more accurate wave energy assessments and forecasting, as well as supporting better site selection, wave energy station design and innovation, and fostering collaboration, aids regulatory decisions, and accelerates the transition to a sustainable energy future. A bit about wave theory. So as waves approach the shore, they experience wave breaking, wave shoaling, which is an increase in wave heights, wave refraction, and rip currents. And there is no reliable method to accurately measure wave conditions in the wave breaking zone and near marine structures. EcoWave Power's wave energy pilot station is used for this study. The station is a 100 kilowatt point absorber station located in Tel Aviv in Israel and is connected to the national electricity grid. For data acquisition, EcoWave Power is analyzing various sensors, which provides accurate wave data for nearshore applications, simple to install and cheap. The first is satellite data, which is our benchmark, which provides hourly resolution and historic data for many locations, and 5 sensors installed nearshore, which provide data at 5 Hertz or 5 times a second and must be installed at specific sites. They are the sensors that were used are the Vegaplus C21 water level radar, Obscape ultrasonic sound sensor, a gyroscope, a wave buoy, and a hydrostatic pressure transducer. Firstly, satellite data is available for many locations around the globe, and usage of wind and uses wind and wave data as well as topography to produce wave hindcasts and nearshore wave studies. The sensors that were deployed are shown below. The water level radar, ultrasonic sensor, and the gyroscope were installed and were able to survive the storms and provide data, whereas the wave buoy and the pressure transducer did not survive the storms, and no data was collected and analyzed for the study. Here's a picture showing the installation of the 3 sensors which survived storms. The radar and the ultrasonic sensors were installed on a mast about 5.3 meters above the waterline, and the gyroscope was installed on the floater arm, which moves up and down with the waves. EcoWave Power compared the radar versus ultrasonic sensors. Waves breaking below the sensor leads to a discrepancy between the radar and the ultrasonic sensors, and EcoWave Power analyzed the discrepancy to better understand what is happening. It was believed that the ultrasonic sensor is recording the splashes from the breaking waves and adversely impacting the sensor readings, therefore not being suitable for the wave breaking zone. Below, you can see 2 graphs of the sensors during storms. On the left, you can see in orange the Obscape sensor, which is the ultrasonic sensor. And during wave conditions, it gave readings of up to 60 meters, which is obviously unrealistic and are seen as errors during the storms. On the right, it's the same graph, but cut for the y-axis from 0 to 2 meters. Here you can see that the Vega radar sensor is a lot more accurate to the satellite sensor readings, and that during storm conditions, all of the ultrasonic sensor readings were unrealistic. As you can see, they were off the chart. It was found that there is a high correlation between the Vega radar sensor and the satellite data, being at a R-squared correlation coefficient of 0.91, and the ultrasonic obscape sensor had a correlation of 0.31. Therefore, we concluded that the Vega sensor is suitable for the wave breaking zone. Additionally, EcoWave Power developed a wave-by-wave analysis, which is the capability to measure the wave height and period for every single wave. The wave energy benefits are higher wave accuracy in wave measurements with measuring individual waves compared to probabilistic conditions such as significant wave height and energy wave period. Also, this leads to higher accuracy in measuring available wave energy at any given point in time. The broader benefits are to be able to develop safer marine structures and research for a wide array of ocean and wave-related applications, including forecasting, climate studies, and additional technologies. Here is a description showing the comparison between statistical and wave-by-wave analysis. The typical value measured to provide sea state conditions for waves is the HS, which is a significant wave height, which is known as the average of the third highest waves. And as you can see, this does not give an accurate representation of the wave conditions because you have the median and the mode being below this condition, and you need the whole spectrum to understand how much energy you have in the sea and how to better capture this energy. So EcoWave Power developed a wave-by-wave analysis tool, which provides in-depth metrics about wave conditions, is capable of measuring individual waves in comparison to broad statistical values. And now I'll give a demonstration of this. Here is a tool where you install or upload your files from the radar sensor. You press Start Analysis, and it provides wave metrics for the sea state for the wave conditions. As you can see, for this particular file which I uploaded, it shows the HS distribution by categories. So whether it's high waves, which is above 0.7 meters, intermediate waves, and low waves, and it gives metrics such as the metrics about the significant wave height and the period of the waves. It provides signal analysis, which is able to show the tide conditions, as well as the maximum and minimum water levels. We're also able to isolate the wave component, which is without the tide factor, and provide a wave spectrum and water level distribution. The x-axis is the water level, which is the distance from the sensor, which is about 5.3 meters above the waterline. Then we proceed to give sea state analysis, which is the HS, TE, the count of the individual waves, the average wave height, the maximum waves during those conditions, and the HMO. We'll then proceed to showing the hourly conditions. So in this particular test, we're looking at 5 days, and the rolling volatility. Whereas the rolling volatility is the the changes of the wave conditions, which can be seen as periods where you have a approaching storm or a receding storm. You have hourly data, with capabilities to generate CSVs and Excel for further advanced analysis, wave distribution analysis, wave period distribution, and a deep dive tool where we're able to take a certain period, like 5 minutes, and see the water level moving up and down. We measure individual waves and wave counts and additional exports. For conclusion, in the wave-breaking zone, only sensors installed above the waterline survive the harsh conditions, and radar measurements offer more consistent wave data and a high accuracy compared to the satellite metocean data. EcoWave Power also developed a tool to provide wave data at a resolution of measuring every wave compared to conventional statistical analysis methods. Thank you for listening to this presentation.